Hello, I am Ranza Karia Shanina. In this video, I'm going to explain pathophysiology of burn injuries. Burn injuries can have significant systemic effects, disrupting several physiological systems and leading to biochemical, fluid, and electrolyte changes. Burns cause both direct tissue injury and systemic inflammatory response, resulting in fluid shifts and changes in electrolyte balance. The damage to the capillary walls increases vascular permeability. Plasma, which contains nutrients, clotting factors, leukocytes, antibodies, cytokines, and growth factors, leak to the interstitial space, causing edema. Fluid loss from the skin surface occurs due to the destruction of the epidermal barrier, causing evaporative water loss. At the same time, there will be fluid leakage from the vessel itself that is accompanied with nitrogen leakage. This causes hyponatremia. Hyponatremia can cause confusion, seizures, and coma. It results from sodium loss. Potassium will be released from the damaged cells, accompanied with the fluid leakage, causing hyperkalemia, high potassium in blood, which may result in fatal arrhythmias or cardiac arrest if severe. However, potassium is lost through urine or shifted intracellularly with treatment, developing later hypokalemia, which can cause muscle weakness, paralysis, and dangerous cardiac arrhythmias. If fluid resuscitation is inadequate, the loss of plasma volume can lead to hypovolemia and decreased cardiac output, which means a decrease in the amount of blood the heart pumps with each beat, as well as organ hypoperfusion, as the reduced blood volume leads to insufficient blood flow to the vital organs, such as the brain, kidneys, liver, and heart. Hypovolemic shock can develop as well. It is a life-threatening condition where the body loses too much blood or fluids, leading to low blood pressure and poor oxygen flow to organs. And metabolic acidosis. Hypovolemia causes poor circulation and reduced oxygen delivery to tissues. When tissues don't receive enough oxygen, they start to produce lactic acid as a byproduct of anaerobic metabolism. Anaerobic metabolism means energy production without oxygen. Now, the buildup of lactic acid in the blood contributes to metabolic acidosis, making the blood more acidic. Let me tell you about the lymphatic system's role now. In the normal situation, the blood from the arteries will go to the capillaries. The fluid from the capillaries will leak to the tissues, about 20 liters of what we call an interstitial fluid. Then about 17 liters from the interstitial fluid will enter to the venal capillaries and go back. But what about the 3 liters remaining? Here comes the lymphatic system's role. Lymphatic capillaries will take any remaining interstitial fluid and return it to the heart. In the normal situation, it is 3 liters. But what about in the burns situation? As I said before, when there is burn tissue, there will be vascular permeability, which means blood vessels will have more pores and there will be more fluid leakage into the interstitial space. Increased blood vessel or capillary permeability allows proteins and fluids to accumulate in the interstitial space. The lymphatic system is overwhelmed and unable to clear the excess fluid effectively, resulting in persistent edema. This edema peaks within 24 to 48 hours post-burn. Burns can lead to significant renal complications, especially if hypovolemia is not managed. Hypovolemia, or low blood volume, is common after severe burns due to fluid loss from the damaged skin and increased vascular permeability. Hypovolemia leads to decreased renal perfusion, which means reduced blood flow to the kidneys, which impairs the kidneys' ability to filter blood effectively. If the kidneys do not receive enough blood, resulting in decreased urine output or oliguria, and the potential for acute kidney injury. Acute kidney injury can range from mild impairment of kidney function to complete kidney failure, where the kidneys are unable to excrete waste products or balance electrolytes.